Hi guys, good morning everyone. Welcome back to my channel. My name is Sai Kiran. Today we are going to discuss about AWS Redshift. Guys, this is the last session for the databases because we have discussed about structured database and we have taken a practical example of SQLDB, and then we have discussed about unstructured database where we have taken an where we did an practical on serverless architecture using DynamoDB, API gateway, Lambda functions. Now AWS Redshift is also part of database, but it is majorly used to handle the large scale data sets, and it is majorly used to handle the fastest performance. Correct. See, we do have different types of databases. We do have different types of databases like SQLDB, MongoDB, Aurora, or OracleDB, DynamoDB, and then DocumentDB. All these were structured and unstructured databases, right? Even if we are having these many databases, then what is the point of using this AWS Redshift, right? I'll tell you something here again. We do have a hard disk drive, correct, which is HDD. What will happen whenever user tries to access some notepad file or some image or something, this is something called a magnetic pendulum. This is a magnetic arm. What will happen? This pendulum will be spinning up at a particular RPM, and the user will be retrieving an information at particular point of time. Correct? Even if we are having HDD, we do have something called SSD, which is a solid state drive. This solid state drive doesn't have any physical components, but it still does have some chips on it for the speed. I mean, for the fast performance. Even if we are having this SSD, we do have something called NVMe, which is non-volatile memory. This is for the fastest IOPS. Even if we are having NVMe, we do have something called M2. Correct? We are having hard disk memory, but still why we are having this all this because of the performance. In same way, imagine guys, in same way we do have KB, we have MB of data, we have ZB of data, we have TB of data, and then we have PB, which is petabytes, exabytes, zettabytes, and then yottabytes. Correct? Even if we are having these many databases, why we are using Redshift is, see, if you keep a petabyte of data in the SQLDB, what will happen is SQLDB is typically opted for the smaller data sets only. If you try to put large amount of data, what will happen? It will suffer to handle the petabytes of data, and it will give you very slower responses, and it will give you weak performance during the time of data retrieval. Correct? But the major advantage of this Redshift is Redshift can easily handle massive data and can easily scale up and down, providing the fastest performance during the time of user retrievals, right? So, see guys, imagine if your data is sitting in a data center. As a human, you will not be going directly to the data center and you will retrieve the data, correct? In between, there is something to retrieve the information to the user, right? So here there is something called Redshift. Today we are going to do a small project on Redshift where we are going to involve the business intelligent people also, which are BI people. I'm going to draw the architecture first. First, we are going to create one Windows instance. Windows instance for what? Windows instance is used to create a Redshift workbench, and then we'll also install Java 8. After that, we are going to create one S3 bucket, and then we are going to put some sample data. Once it is done, we'll log into our Windows machine and we'll able to retrieve this information inside the S3 bucket. Okay, till here, as a DevOps engineer, your part is done. So here comes there is someone called business intelligence engineers. So what these people will do is they will retrieve the information into an service which is something called AWS QuickSight. And what this QuickSight will do is it will take all the information from the S3, or it will take all the information from this RDS, I mean Redshift workbench, and it will create an interface, graphical interface. Okay. What is the point of creating this graphical interface is, imagine guys, you are having an meeting with CEO, or you're a part of quality or quality analysis team. So don't take me in a wrong way. if you're entering some SQL queries and if you're showing some output to your CO, he will not understand because he should it's your responsibility to show him clearly what was the exact task going on, what was the percentage of things are going on, what is your future plan, and all these things in an pictorial representation way, right? So for that we have something called AWS QuickSight. Now let's go and achieve this task. Let me pull it to my console.
So here is the console, guys. First, what I'm going to do is first we're going to create one EC2 instance. I'll click on launch instance. I'll select Windows and then I'm going to select 2019. Take T2 medium or T2 large because it will take 30 GB in the backend. So T2 free version will not be sufficient. Select VPC, public subnet, enable. If you wanted to select private, you can select, but make sure that you are adding a NAT gateway to it. Okay, and then create launch instance. Once this is done, what you have to do is go to the Redshift, Amazon Redshift. I'm sorry, I have opened a new tab. Before creating the cluster, first what you have to do is you have to go to the configurations and you have to create the subnet group first. And then you have to create the cluster. I have already subnet group. I'll delete this. It's not required. I'm going to show you how to create. Leave the name as it is. Make sure you're pasting the description and selecting the VPC. Allowing it to all subnets. That's the reason why I have added all the subnets here. Okay. And then create subnet group cluster. Once this is done, what you have to do, you have to go and create the cluster. Click on clusters, create cluster, leaving the name as it is, and make sure you're selecting the D2 large. D2 large is sufficient, and number of nodes, one is enough. Load sample data. I'm not going to load any sample data because we already do have the sample data. I'm going to give this as admin I, and then I'm going to take my own password. Scroll down. Make sure you're selecting the VPCs accordingly. Select your VPC. Remove the default security groups. I do have my security groups. This is the subnet group we have created, right? Cluster subnet group 1. Refresh. Yeah, this is the one. No preferences. You can enhance VPC turning off. And then publicly accessible, I'm turning it on. Elastic IP was not there for me, so I'm leaving it as none. Guys, make sure in real time you're not supposed to turn on this publicly accessible. If you're turning on publicly accessible, make sure that you're attaching an elastic IP here. Okay, and then leave everything as default and then create cluster. Once this is done, go back to your Windows instance and try to log into the server. Now we have to install Chrome, Java 8, and then we have to install one RDS workbench. Connect, get password, decrypt, copy, and then it will take some time for login. Here is the console. Now I'm going to open Edge. This Edge has been installed just now only, and I'm going to download Java 8. Scroll down. Here it is. Click on it. Select and then download. Okay, Java is getting downloaded. Once it is downloaded, make sure you're installing it. Okay, our Java 8 has been successfully installed in our remote session. Now, once this is done, what you have to do is minimize this, go to S3 bucket, and make sure you're uploading some sample data into your S3 bucket. Meanwhile, I'll refresh this whether if it is up or not. Okay, it's unavailable. See, now it is available. Nice. Okay, scroll up and then go to your S3 bucket, create one bucket. I'm going to give the bucket name as testing, just a random name. You can give whatever you want. Scroll down, give the public access to it. I agree. And then create a bucket. Create a folder here inside your bucket, folder called data, and then create a folder. Now you have to upload the data here. See, yes, this is the sample data I do have. Do not worry, this data is something which is related to the part, which is a supply chain. Okay, part name, part name, customer number, customer even all the random data which I was generated from the GPT. Okay, and I'm going to upload all this here. Upload. So once this is done, what you have to do, you have to go back to your Redshift and make sure you're downloading the drivers. This is a JDBC driver. Download the driver now. Store it under downloads. I'll be going to that folder. I'm going to copy this. Open your remote session. This is our remote session. Minimize and paste the drivers under C drive. Once this is done, what you have to do next? I do have workbench zip file here. I'm going to paste the workbench zip file also here and I'm going to extract it here. Okay, now I'm going to extract my workbench. Extract all. Extract. You can delete the previous workbench. I mean the zip file. If you scroll down, if you open the workbench and if you scroll down, there is something called SQL Workbench 64. Okay, SQL Workbench 64. Double click on it. Manage drivers and then select Amazon Redshift. Make sure you're removing this artifact. And which artifact you have to add is you have just uploaded an artifact here, right? Under C drive. Go to the artifact. See, this is the artifact you have downloaded, JDBC drivers 4.2. So you have to add this artifact here. Open and then select OK. Once this is done, give the name as whatever you want. I'll be giving it as testing and then select Amazon Redshift under the drivers. And when it comes to the URL, go back to the Redshift again here. If you select this Redshift cluster, then you can able to copy one URL here, paste it. What was your username? My username is admin and then my password is auto commit and then click on OK. See, I have successfully logged into my SQL workbench now, right? Not SQL workbench, I mean this Redshift workbench. Okay, now what I'm going to do is I'm going to enter some queries here and we'll see how it behaves. Guys, I do have a predefined queries. So I have prepared it from the GPT tool again. I'm going to give you all these things, do not worry. If I enter this query and if I run, see, I can see only table name here. Apart from this, I couldn't able to see anything. Correct? Now I'm going to open new tab. I'm going to add some data here now. Okay, I'm going to add some data here. See, this is the data. See, supply key, name, address, city, nation, region, phone. This is just a sample data. Don't think that it is something like different. And then I'm going to add the data and I'm going to click on run. It's okay. Some errors were there when adding the data, but it's okay. Limited data is fine for you to show the example. So I'm going to ignore some errors. Some data has been added here. Okay. Now if I enter, I'll take new tab, select everything from part. I'm sorry. Select everything from part. See here, now I can able to see just the index names which are part key, part name, manufacturer, category, brand, but I am not able to see any part details here. In order to see the part details, what I have to do, we just have uploaded and data in our S3 bucket, correct? See, this is our data. All the data, customer information, all the part keys, names, colors, all the data has been here. But we can only see the index names here. Now what we have to do is we have to run the s3 command to retrieve the information from there. What was my s3 command? Copy your s3 bucket name. This is my s3 bucket name, and then data, and then csv. The reason why we are doing this is because in real time we'll be storing all the backups in our s3, right? So here also I did the same. I am keeping some data in the s3 and I'm able to retrieving the information from the workbench. Now, and then I have to create one access key and secret key. Do not worry, I'm going to delete this access key and secret keys once the session has been done. I'll open IAM. I'll give only S3 full access. I'll create one user now. Remind me later. And then users, create a user, testing. Click on next, attach policies, S3 full access. Oh, S3 full access. Click on next and then create user. Get into the user, security credentials, create access key, other, next, create access key. Make sure you're copying the access key and secret key and pasting in our SQL query. Paste it here and then copy the secret key and then paste the secret key here. Now what you have to do, copy the entire query, copy it, paste it in our workbench. Before, what it is showing, it was showing only part key, part name and manufacturer, but the details were not there here, right? Now see what will happen. We are able to retrieve the information from S3. Now I'll simply click on run. See, it will take all the information here. See, copy executed. Some 49,999 parts were loaded successfully. And if I run this query again, see, I'm able to see all the details here now. Imagine I have just added only minimal data, but if you added petabytes of data, it will be really quick. Like just how quick the information has been grabbed right now, it will be really quick in the same way itself. Only that is the reason why we will use Redshift. Now, as a DevOps engineer, as I said before in the diagram, our part is done. We have created an S3, we have created one instance first, and then we have created an S3. We have added some data there, and we have created our workbench in a remote session. We have copied some drivers. Till here your part is done. Now there is something called business intelligence engineers. What they're going to do is they're going to open AWS QuickSight, and then what they're going to do with the help of QuickSight, I told you in the diagram already. They are going to put all this data in a graphical way, correct? Click on datasets, click on new datasets, select Redshift, give the name as whatever you want, select your cluster ID, public network, dev, database name, whatever you want to give, you can give. What was the username here? Admin Sai. And what was the password? And then simply click on create data source, and it is connecting now, validated. Which data you wanted to showcase? I wanted to showcase part data, and I'm going to select it. and I'm going to click on visualize. Then simply click on create. Here you can select the flow chart. Okay, I'm going to select this flow chart and I'm going to add the part color. Add to visual. See the part color here, how good it is. Got it? Now if you wanted to add anything like name, see here what were the different types of parts were there. Indigo. Now as you see, AI has been generated some different names here. Yellow, frosted, floral, orange, yellow, different parts were there. Now, oh, I've added name. Okay, I'm sorry. Now I'll add part key. Add to visual. White, Testel Spring, Peru. So this is how it works, guys. This is what business intelligence, I mean BI people does. I'm going to change the chart. Let's change the chart to some, see here. Good. And then if I wanted to change, you can play with it. I'm just selecting randomly. You can play with it. You have all. I'll be posting all this data in our repository. Do not worry. So as I said before in the diagram, if you have any sessions with CEO or if you have any sessions with your manager, so this is the best way to showcase them instead of showing them like what you did and what is the output and all. If you show them in an like this table representation way, then it will be most easy for them to understand the process also. Okay. Now that's all I wanted to show you. If you wanted to do something more, you can copy all this and you can open Excel sheet. I have also tried to learn Glue and Athena, but it was taking so much of time to post videos, so I avoided those two, Glue and Athena. But in future, yes, we'll do some videos on it. Now, if you paste all the data here, and if you wanted to, yeah, if you select all the data, and if you go to the insert, and if you click on recommended charts, you'll be able to see the recommended charts here. Okay, and if I want this chart, and if I click on OK, see, this is what I wanted to show you guys. This is how Redshift works actually. If you have any doubts, please put it in the comment section, or if you wanted me to suggest something on the Redshift, please put it in the comment section. I also wanted to deep dive and learn something about Redshift, and it's in the same way how this AWS Glue and then AWS Athena works. So we'll definitely look into that in future sessions if we have time, because those were completely an data analysis and analytics tools. That's all for today, guys. We're going to meet in the tomorrow's session. Please put it in the comment section if you have any doubts, and also you can connect to me over LinkedIn. Thank you so much, everyone. Have a nice day. Bye bye.